Hi students, this is Shekhar sir. Today I will explain about electric current. So we know that without electricity, without electric current, we cannot imagine this world. So we know that the machines as well as electric bulb is glowing. Everything is working behind the electric current. Okay, electric current లేనిది మన లైఫ్ లో ఏదైనా చేయలేము. కరెంట్ అనేది చాలా ఇంపార్టెంట్. సో according to what does mean electric current? So here I taken as a conductor. This is a conductor length L. So in this case, conductor is in the open circuit. Open circuit means it is not connected to the any external source battery. It is not connected to the external battery. So when the conductor is in open, here the electrons are moving randomly each other. For example, here in this case, one electron going like this, one electron going like this, one electron going like this, like this, like this. So due to the due to the your room temperature, due to the room temperature, the electrons are moving randomly each other at a speed. Here the speed is for example, here the electrons are moving with the speed 10 power 5 meter per second. In that much speed, okay now. So at room temperature, the energy between kinetic energy between molecules, electrons is increases. Then the electrons are moving randomly each other with the speed 10 power 5 meter per second. So what is the average thermal velocity? Here average thermal velocity, V average thermal velocity is u1 plus u2 plus here and so on plus un by n equal to, here it is 0. So average thermal velocity is 0. So net flow of charge, here net flow of charge is 0 because, so here left to right the electrons are moving equal to right to left. So we cannot say how much electrons are moving from left to right. We cannot say how much electrons are moving from right to left. So here net flow of electrons is 0. So electrons are moving open conductor ఉన్నప్పుడు the electrons are moving randomly each other. The electrons are moving randomly each other with a speed 10 power 5 meter per second due to the thermal energy between the atoms, between the electrons. So here thermal velocity, average thermal velocity equal to 0. But when we connect this conductor to a external battery, what will happen? Here when we connect this conductor, this is the conductor. When we connect this conductor to a external source battery, here it is a battery is there. When we connect it to this conductor to a battery, here it is a key is there. When I switch on the battery, here when I switch on the battery, the current always flows from in a circuit positive terminal to the negative terminal in a circuit. So the current is flowing this direction. The current is flowing this direction. So the electrons are moving in a order way. When we connect a conductor to a battery, the electrons are flowing in this direction. So there is when we observe this, when we connect conductor to a, for example, this is a conductor. When we connect the conductor to a external source battery, the electrons are orderly moving. Now the electrons are orderly moving. So here the ordered flow of electrons is called as a current. The ordered flow of electric current means the ordered motion of electric current means the ordered motion of electrons. The ordered motion of electrons is called electric current. Here the electrons, when we connect, okay, the conductor without connecting battery, okay, if you are not connecting battery, the electrons are moving randomly each other. Like for example, if teacher is not there in the class, the students are moving randomly each other, this direction, that direction, that direction. So when the teacher is coming, means the students are sitting properly. So in the same way, okay, in the same way, okay, now if you are not connected to a battery, the electrons are moving randomly each other. But when we connected to a battery, here the electrons are orderly moving. In this case, the electrons are orderly moving. So the order flow of electrons is called as a electric current. So here other definitions are current I equal to the rate of flow of charge. For example, here I taken as a cross section area, this cross section area. So here in this cross section, how much charge is flowing? Here how much charge is flowing is called as a current. So current I equal to Q by T. Current I equal to Q by T. Q means charge. Q means charge. So current I equal to charge by time. So in this cross section, for example, in this cross section, here 2 coulombs of charges passing in 1 second. So here 2 coulombs of charge is passing in 1 second. In time is 1 second. So here I defined as a current. The 2 coulombs of charge passing through this cross section for 1 second is defined as a current. For 1 second is defined as a current. So here I am assuming here as a 1 coulomb charge. So the 1 coulomb charge is passing any cross section of this conductor per 1 second is defined as a 1 ampere. Is defined as a 1 ampere. So here 1 ampere equal to 1 coulomb per 1 second. So here negative charge is flowing. So the rate of flow of negative charge through any cross section of this conductor per time. Okay, now per time is called as a electric current. So when it comes to the electrolyte solutions, for example, NaCl is a electrolytic solution. So in the electrolytic solution, so in this case, the positive ions are moving, positive charge is moving, as well as a negative charge is moving. Here it divided into Na plus Cl minus. In the electrolytic solutions, the current is because of the motion of the ions. The current is because of the motion of the ions. Here Na plus ions is moving, positive ions are moving, as well as the negative ions are moving. But when it comes to the electric conductor, solid conductors like metals, the current is flowing due to the ordered flow of negative charge. The flow of negative charge through this cross section area per time is called as a current. Current means the flow of charge. What is the charge? Here the charge is the electrons. The flow of electrons per time is called as a electric current. For example, here 1 ampere is defined as a 1 coulomb charge. 1 coulomb charge passing through this cross section per 1 second. Per 1 second is called as a 1 ampere. So here 1 ampere, 1 coulomb equal to, we know that 6.25 into 10 power 18 electrons. 10 power 18 electrons by 1 second. By 1 second. So in 1 second, how much electrons are moving in this circuit? How many electrons are moving? 6.25 into 10 power 18 electrons are moving, because we know that 1 coulomb equal to how many electrons? Here 1 coulomb charge equal to 6.25 into 10 power 18 electrons. 10 power 18 electrons. So in the 1 ampere current, the 1 charge is flowing for 1 second. 1 charge is flowing 1 second. 1 charge means 6.25 electrons, 6.25 into 10 power 18 electrons are moving in 1 second, which is equal to 1 ampere current. Which is equal to 1 ampere current. So this is about current. Next, what is the SI unit of electric current? So here SI unit is ampere. SI unit is ampere. Next, what is the dimensional formula? Here dimensional formula. Here dimensional formula is capital I or capital A. Capital I or capital A. Remaining fundamental quantities are all are equal to 0. So here we can say that N0, L0, T0, capital I or capital E. So this is the dimension formula of a electric current. This is about electric current. So electric current means the ordered motion of electrons is called as a electric current. Or we can say that the rate of flow of charge through this cross section of a conductor per unit time is called as a electric current. So electric current I equal to charge by time. So 1 ampere is defined as a 1 coulomb charge passing through this cross section area of a conductor per 1 second is called as a 1 ampere. So in 1 ampere how much electrons are moving? So in 1 ampere current there are flow of 6.25 into 10 power electron 18 electrons are flowing. So SI unit of current is a ampere. Dimension formula is a I, capital I or capital A. Next thing is a instantaneous current. What does mean instantaneous current? So when it comes to the instantaneous current, the rate of flow of charge is not constant. The rate of flow of charge is not constant in the instantaneous current. Here in this case, instantaneous current, we have to take the time limit equal to 0. We have to take the time limit equal to 0. Here instantaneous current instantaneous current case, the rate of flow of charge is not constant. The rate of flow of charge is not constant. Then the current is called instantaneous current. Here we know that current formula I equal to Q by T. Current formula I equal to Q by T. But instantaneous current is time limit we are taking it to the 0. So here I equal to time limit delta when delta t tends to 0 limit when delta t tends to 0 delta q by delta t equal to dq by dt. When we take the time limit becomes 0, okay na, becomes 0, then delta q by delta t equal to dq by dt. Here dq by dt. So here current I equal to dq by dt, or we can write it as a dq equal to I into dt. Here we can write it as a dq equal to I into dt. So based on this formula we can solve the two numerical questions, then we can understand better. Here one numerical question, the rate of flow of charge is q. The rate of flow of charge is qt equal to 3t square plus 5t plus 2. So the rate of flow of charge qt equal to 3t square plus 5t plus 2 is varies with time. T equal to 2 seconds. Find the instantaneous current. So here Q represent charge, T represent time. T represent time. So this is the question. The rate of flow of charge qt equal to 3t square plus 5t plus 2. Okay, this varies with time t equal to 2 seconds. Find the instantaneous current. In this case, q is the charge, t is the time. T is the time. Look at your formula here. I equal to, we know that instantaneous current I equal to dq by dt. dq by dt. So here d by dt of what is given 3t square plus 5t plus 2. So when you differentiate with respect to time, then the equation will becomes here it is 0 to 2 seconds. Then the equation will become 6 into 2, 6 into t plus 5. Plus 5. Here it is 0 to 2 seconds. When you put your limits, here is 12 plus 5. Here it is 17 amperes are coming current. So this is the equation. So when you differentiate this equation with respect to time, so here we know that, for example, d by dx of x power n, d by dx of x power n equal to n into x power n minus 1, n into x power n minus 1. Here 3t square is d by dt of 3t square equal to 2 into here 3 into t power 2 minus 1, which is equal to 6 into t, which is equal to 6 into 3t. So this is a formula to find the differentiation. Differentiation means d by dx of x power n equal to n into x power n minus 1. So this is the equation. This is important for JEE mains as well as the NEET. So the rate of flow of charge is varies with time. Qt equal to how much given? 3t square plus 5t plus 2 is varies with time t equal to 2 seconds. Find the instantaneous current. In this case, q represents the charge, t represents the time. So we know that I equal to dq by dt. So d by dt of q. Q means 3t square plus 5t plus 2. With respect to limits 0 to time. Time varies from 0 to 2 seconds. So here when we differentiate with respect to time, here 60 plus 5 limits 0 to 2. Here it is we are getting the 17 amperes. So this is the when the how to find the instantaneous current when the charge is not constant. When the charge is not constant. Here I am giving one numerical question for you. Here it is you can solve it and put in the comment box. Here charge qt equal to 40 square minus 70 plus 40 cube minus 70 square plus 2t. Time varies from t equal to 1 second to 2 second. 1 second to 2 second. Okay, solve this and put in the comment how much current is coming through this charge. Okay, now when the charges varies with the time, how much current is coming? Okay, you have to solve it and put in the comment box. Next thing is when the current is changing, with the time, how to find the instantaneous current when the rate of flow of current is changing with the time. When the rate of flow of current changing with the time. Rate of flow of current changing with the time. Here instantaneous current I equal to we know that dq by dt. Here dq equal to I into dt. dq equal to I into dt. So for example here the rate of flow of current. Next question, the rate of flow of current. The rate of flow of current is varies with time. Here I is given I equal to 40 plus 60 square. I equal to 40 plus 60 square. Varies with the time here. Varies with the time t equal to 1 second to t equal to 3 seconds. T equal to 1 second to 3 equal to 3 seconds. find the instantaneous current. Find the instantaneous current. So put in the formula. I equal instantaneous current, I equal to dq by dt. dq equal to I into dt. So here we know that find the instantaneous charge. Find the instantaneous charge. Look at here. Find the charge. Here charge dq equal to I into dt. Charge dq equal to I into dt. So dq equal to, here I is, what is the I? 40 plus 60 square. So when you integrate with respect to time. So this is the integration with respect to time. So integration of x power n equal to x power n into dx. Integration of x power n into dx equal to x power n plus 1 by n plus 1. X power n plus 1 by n plus 1. So here in this current we have to differentiate with respect to dt, time, with respect to time. Here 4 is constant. 4. Next it is a t square by 2 plus 6 into t cube by 3. 6 into t cube by 3. Limits here it is a varies with the limits of 1 to 2. Here varies with the limit 1 to 3. Varies with the limit 1 to 3. Solve it here. 2 ones, 2 twos. 3 ones, 3 twos. Here 2 2 square, 2t square plus, here what is 2t cube. Limits varies with 1 to 3. First you put in the 3. Here when you put the 3 here, we will get 3t square means 9, 18 plus, here we will get 27 into 2, 54. 54 minus, when we apply 2, 1 here, 1 put in the here 2 plus 2, 4 minus 4. Here is you will get 68. You will get is a 68 coulombs charge. 68 coulombs charge. So this is how to find the instantaneous charge, instantaneous current. Okay, now by using the equations. So here the rate of flow of current they are giving that I equal to 40 plus 60 square. Varies with time t equal to 1 second to t equal to 3 seconds. Find the instantaneous charge. So we know that I equal to dq by dt. dq equal to I into dt. So when you put here I, here 40 plus 60 square. So here we have to integrate. Integration formula, integration of x power n into dx equal to x power n plus 1 by n plus 1. So here 40 and t power 1 plus 1 by 1 plus 1, t square by 2. Here t power 2 plus 1 by 2 plus 1. Here 6 into t cube by 3. So it is varies with the time limits of 1 to 2. When you apply in place of time, we have to apply 3 and 1. We will get the charge. Charge equal to 68 coulombs. Charge equal to 68 coulombs. This is how to find the instantaneous current as well as the instantaneous charge. Here also I am giving one numerical question. Okay, now try yourself. Put in the comment box. Here I equal to 5t square plus 70 cube plus t. It is a varies with the time t equal to 1 second to t equal to 1 second to 3 seconds. Find the charge. Pause this video and write the question, write the answer and put in the comment box. Okay, now I equal to 5t square plus 70. Here 5t cube plus 70 square plus t. When time varies limit 1 second to 3 seconds. Okay, now next thing is we know that when the current is flowing through the straight conductor. If the current is flowing through the straight conductor, I equal to q by t. But here in this case, if the electrons are infinity is there, if the electrons are n, 10 electrons means 10 into Q by T. Charge. So for example, in the current I equal to, we know that Q by T. I equal to Q by T. Okay now. For example, in terms of a charge, I equal to E by T. In terms of a charge, I equal to E by T. For example, in the circuit, there are n electrons are there. There are a circuit, n electrons are there. So the current I equal to n into Q by T. Okay, I equal to n into Q by T. So in a, for example, in this case, conductor will be taken as a here length L. So for example, total n electrons are there. 1 electrons means Q by T. For example, here, okay, if the current is flowing through the number of electrons, total number of electrons, the charge is flowing through the total number of electrons, I equal to n into Q by T. I equal to n into Q by T. It is the translator motion of a charge. But what will happen if the charge, electric current, electric charge, what will happen? Electric charge flows through a circular path. Flows through a circular path. What happens when a charge flows through a circular path? For example, this is we can take it as a circular path. So in this circular path, the charge is flowing. Okay, in this circular path, the charge is flowing. As in the circular path radius is R. Here it is a charge is flowing in this direction. So we know that when the charge is flowing in this direction, the velocity is at a tangential path. The velocity is acting at a tangential path. So here we know that time period T equal to total distance by speed. Okay, now distance by speed equal to here V. Time period T equal to 2 pi R by V. Distance by speed. Here we can say that frequency equal to 1 by time period. Frequency equal to, we can say that V by 2 pi R. Frequency equal to V by 2 pi R. So put in the formula. Here we know that current I equal to charge by time. Here time is Q by time, how much? 2 pi R by, here charge is V. 2 pi R by V. So here V will go numerator V. We can charge as a Q. Here we can take a charge as a small q. Then this formula VQ by 2 pi R. VQ by 2 pi R. Okay, now so here I equal to, we can write as a current I equal to V into Q by 2 pi R. V into Q by 2 pi R. Or we can write as a I equal to current I equal to here V by R equal to omega Q by 2 pi R. Omega Q by 2 pi R. This is how to find the current in a, when an electron is revolving in a circular path. When an electron is revolving in a circular path. So how to find the current? Current I equal to VQ by 2 pi R. For example, here in this case, the electron is moving in a nucleus of a hydrogen atom with the speed 2.25, or we can write as 2.25 into 10 power minus 4 meter per second. Okay, with the speed 2.25 into 10 power minus 4 meter per second. Here radius equal to 10 angstrom. Next, charge of electron equal to 1.6 into 10 power minus 19. Charge of electron equal to 1.6 into 10 power minus 19 coulombs. So put here, you will get the answer. This is one question for you. This is the third question for you in this lesson. So when the charge is flowing through the circular path. For example, this is the circular path radius is R. So here the charge is Q. So it is moving in a circular path. So what is the current in a circular path? So current I equal to VQ by 2 pi R, or I equal to omega into q by 2 pi r. Here V says that speed. Okay, the speed of electron. Next q is the charge. Next r is the radius of the circular path. Here omega is the angular velocity. Omega is the angular velocity. So this is the how to find current when a charge is flowing in a circular path. Okay, now when you put here this formula, you will get how much current is flowing through the circuit. Okay, now put in the comment box, solve this problem and put in the comment box how much current is flowing through the given circuit. Next thing is here. Okay, now once again we have to recall when the current flows through the circular path. Here time period equal to distance by time 2 pi r by v. So here frequency equal to 1 by time period. Here frequency equal to v by 2 pi r. So when we write here I equal to q by t. So q by 2 pi r by v. So it is equal to vq by 2 pi r. But we know that angular velocity omega equal to v by r. Angular velocity omega equal to v by r. When you put v by r place omega, so I equal to omega into q by 2 pi. This is the current when the charge is flowing in a circular path. Okay, now solve this numerical question. Put in the comment box. Next thing is is current scalar or vector? Is current scalar or vector? Current has a direction. Okay, now current has a direction, but even though current has a direction, it does not follow the law of vector addition. It does not follow the law of vector addition. So the current is a scalar. Okay, now current has a direction. Current has a direction as well as a magnitude, but the current is a scalar. Current is a scalar quantity because it does not follow the law of vector addition. For example, the current I1 is coming this direction. Next, the current I2 is coming this direction. The current I2 is coming direction. So whatever the angle between I1 and I2, whatever the angle between I1 and I2. So here is the total current is I equal to, just we have to add I1 plus I2. Current I equal to I1 plus I2. So here we are not following the law of vector addition. So how to add the vector means we have to take the parallelogram of law of vector addition. When we add vectors, we have to follow the parallelogram law of vector addition. Law of vector addition. We have to consider the angle. When we add vectors, we have to take in the angle. Okay, now based on the angle, then the addition is there. Okay, now maximum eppudu untundi, minimum eppudu untundante based on the angle. But even though, okay, now here current is I1 current is coming this direction, I2 is coming in this direction. At this point here, at this junction point, again the current is flowing through in this path. So total current how much means I equal to I1 plus I2. Just we are not considering the angle. ఈ కేసులో మనం యాంగిల్ అనేది కన్సిడర్ చేయట్లేదు. సో I equal to I1 plus I2. For example, here 2 ampere current is coming. Here 3 ampere current is coming. What is the total flow of current means? And is 2 plus 3. It is 5 ampere is the total flow of current. So this is about electric current. So electric current is a scalar quantity. Okay, now once again I recall I equal to charge by time. SI unit is ampere. SI unit is ampere. Dimension formula is IR capital A. IR capital A. IR capital A. Okay, for example, n number of electrons are there means current equal to n into q by t. Okay, if the charge is flowing in a circular path, what is the current? What is the current? Current I equal to VQ into VQ by 2 pi r. Or current I equal to omega q by 2 pi. Omega q by 2 pi. Next, instantaneous current. Instantaneous current I equal to dq by dt. Okay, now this is what we have learnt this video. Okay, in video em nechukunnam ante current definition, SI unit, De Mains formula. Next, instantaneous current. Next, when n number of electrons are going, current equal to n cube by T. For example, if the charge is flowing in a circular path, current equal to I equal to V cube by 2 pi R, or I equal to omega cube by 2 pi. Omega I equal to omega cube by 2 pi. Okay, the current is there, as well as the direction is there, current as a magnitude is there. But it does not follow the law of vector addition. Just simply we have to add like a scalar. Scalar means 3 kg plus 5 kg equal to how much? 8 kg. In the same way, 2 ampere current is coming, 3 ampere is current is coming. Here is the angle is there. We have to neglect the angle. So total current I equal to I1 plus I2. 2 ampere plus 3 amperes, which is equal to 5 amperes. So current is a scalar quantity. It is not a vector quantity. So please like my video, subscribe it, share to your friends, comment the 3 questions in the comment box. Thank you.